Hello everyone, today we will learn about binomial theorem. Any algebraic expression containing two terms, that is, let us say x plus y, x plus 2, x plus 4, etc., is called a binomial expression. Bi means two, so two expression. The general form of binomial expression is x plus a, and the expansion x plus a to the power n, where n belongs to natural number, is called binomial theorem. That means x plus a, x plus 2 to the power 2, x plus 2 to the power minus 2. Those are known as binomial theorem. Now, what is the theorem? Theorem is if x and a are real numbers, then for all n belongs to natural number, this is the expansion of binomial theorem. X plus a whole to the power n equals to nc0, x to the power 1, a to the power 0. See, we have to start from 0, and for first part we have to start from n, and second part power is same as here, nc0, x to the power n, a to the power 0, plus then increase by 1, nc1, x to the power, and power of x to the power n would be decreased by 1. So nc1, x to the power n minus 1, a to the power 1. Next term would be nc2, x to the power n minus 2, a square. In this way, we can say that our general term would be ncr, x to the power n minus r, a to the power r, and the last term would be, see, last term would be n minus 1, 0. So x to the power 0, and here 1, 1, 2, 3, 4, 5, up to, it will go up to n. So ncn, and it will go up to n, 0 to n. So ncn, x to the power 0, a to the power n. This is your binomial theorem. And if you want to write it in the general term, so your general term would be this: x plus a to the power n would be summation r equals to 0 to n, ncr, x to the power n minus r, a to the power n. Put any value, let us say r equals to 0. So we will get first term nc0, x to the power n, a to the power 0, plus, here is summation means plus, r equals to 2, r equals to 1. So nc1, x to the power n minus 1, a to the power 1. That's why this term is known as general term. Now remember some important points. The sum of the indices of x and a in each term is n. See, n plus 0 is n, n minus 1 plus 1 is n, n minus 2 plus 2 is n. So sum of indices of x and a is n. Now what is this c term? This c term is called combination. We will learn it about in the chapter permutation and combination. So c is combination. Always remember NCR formula is n factorial by r factorial into n minus r factorial. This is the formula of combination, NCR. NCR is n factorial by r factorial into n minus r factorial. Now what is factorial? Any factorial. Factorial is 1 into 2 into 3 up to n. So you have to multiply each term, only you will get n factorial. If you stop here, let us say 1 into n, sorry, I am extending, sorry, this would be n into n minus 1, n minus 2 up to 3, 2, 1. So in the previous thing I have written down from the right hand side, but you have to write it down from the left hand side. So n into n minus 1, n minus 2, that is decreased by 1. Let us take one example. If we have 5 factorial, then we will have n, that is 5, into n minus 1, that is 4, into n minus 2, that is 3, again 2, again 1. So 5, 4, 3, 2, 1. Multiply, you will get 5 factorial. Now see, if we have let us say if we want to stop somewhere, let us say we want to stop n minus 1 up to n minus 1. So you have to give factorial. That means we have stopped here. So how can we write 5 factorial? We can write 5 into 4. Let us say we have to stop here. So we have to write 3 factorial, because if we break 3 factorial, it will be 3, 2, 1. So if we write it, if we have written factorial here, that means we have stopped here. So 5, 4, 3. This is the thing you have to remember. And C stands for combination and P stands for permutation. So NPR would be n factorial divided by n minus r factorial. n factorial divided by r minus 1 factorial. P is known as permutation, C is known as combination. If you notice these two things, NCR and NPR, you will notice that here only extra term is R factorial. So from this we can write NCR equals to n factorial by n minus R factorial is what? NPR. So we can write NPR divided by R factorial. So ultimately we can write any permutation, that is NPR, equals to R factorial times NCR. Remember this also, because we will use this in binomial expansion sums. See, and this is the another formula, NCR. Always remember NCR equals to NC n minus R. NC n minus R. NCR is always equals to NC n minus R. That means NC0 would be NC n minus 0, that is NCn. NCR equals to NC0 equals to NCn. What would be NC1? NC1 would be NC n minus 1. NC1 would be NC n minus 1. So how can we write NC, let us say 6C3. What would be 6C3? 6C3 would be 6C n minus 3, that is 3. 6C3 would be 6C3, that doesn't mean. So let us say 6C4. 6C4 would be NC n minus R, that is 6 minus 4. 6 minus 4 is 2. So 6C4 value is equal to 6C2 value. Remember this is extremely important, because whenever there will be higher coefficients, we will reduce to lower coefficients in order to calculate very fast. Now replace A by minus A, A by minus A. Here if we replace A by minus A, then here odd term would be negative. Here odd term would be negative. Odd term, see NC1. Again NC3 would be negative. We don't know the last term, it may be positive, it may be negative. That's why we have given minus 1 to the power n here. General term would be x minus a whole to the power n. General term would be minus 1 to the power r. NCR x to the power n minus r, a to the power r. Put one value. Let us say r0. Minus 1 to the power 0 is 1. NC0 x to the power n, a to the power 0. NC0 x to the power n, a to the power 0. Next term is 1. Minus 1 to the power 1 is minus 1. So minus sign. NC1 x to the power n minus 1, a to the power 1. NC1 x to the power n minus 1, a to the power 1. Okay, I think you have understood this. Now put x equals to 1 and a equals to x here. Put x equals to 1 and a equals to x here. So our expansion would be 1 plus x. 1 plus x expansion, that means put x equals to 1 here. So that means we don't have to write x terms, right? Because 1 to the power something is 1. So our x term, and here x terms will be omitted out, and in place of a we will write x. So x to the power 0, x to the power 0, here we have nothing, that means x to the power 0, then x to the power 1, then x to the power 2, up to this x to the power n. Put x equals to 1 and a equals to minus x, so we will get 1 minus x to the power n. So in 1 minus x to the power n, we will have minus 1 to the power r, NCR x to the power r. The coefficient of x to the power r in the expansion of 1 plus x, see, coefficient of x to the power r. What is the coefficient of x to the power r? That is NCR. Sometimes we have to find out the coefficient. We will see in the problems. Now see, add these two terms, x plus a whole to the power n and x minus a whole to the power n. If you add this, you will notice that we will have only even terms. See, we will have only even terms, twice common. If we subtract this, x plus a to the power n minus x minus a to the power n, subtract this, we will have odd terms. We will have only odd terms, addition of odd terms in the bracket twice. If n is odd, then this term, this thing. If n is odd, that is the number of terms should be odd. If n is odd, and in this thing and this thing, both of them have the same number of terms, that is 2 term, 3 term, 4 term, and that number of term would be equals to n plus 1 by 2. If n is even, then this positive term would be this positive term, x plus a to the power n plus x minus a to the power n will have n by 2 plus 1 terms. If n is even, then this minus term, x plus a to the power n minus x minus a to the power n, will have n by 2 number of terms. Now we will see some problems in order to understand this topic very clearly. Now remember one thing I forgot, that is 0 factorial is always 1. This is also very important. 0 factorial is always 1. Now let us see some problems. So let us see some problems related to binomial theorem. First question is expand by binomial theorem 2x minus 3y to the power 4. See, we can write this term as 2x minus 3y, we can write this term as a plus b or x plus y. So 2x plus or minus 3y to the power 4. That means we have to write the terms up to 4 terms. Okay. So what is our formula? Our formula is NC0, that is 4C0, a to the power n, 2x to the power n, b to the power 0, b to the power 0. This coefficient and this coefficient would be same, right? I have already told you. Next, second term would be 4C NC1, that is 4C1, a to the power n minus 1, that is 2x to the power 4 minus 1, that is 3, and this coefficient and this coefficient would be same, that is minus 3y to the power 1. Then continue up to 4, NC4, then this term would be 4 minus 4 0, that term is omitted, and this term would be minus 3y to the power n. What is n? N is 4. So up to 4 terms we have simplified this term. Now see, let us solve some, let's see what is the value of 4C1, 4C2, 4C0. See, 4C0, 4C0, n factorial, that is 4 factorial, divided by r factorial, that is 0 factorial, into n minus r factorial, that is 4 minus 0 factorial. So you will have 4 factorial divided by 0 factorial is 1, I have already told you. 4 minus 0 is 4, 4 factorial. So 4 factorial cancels out. So we will get 1. So that means you can remember this as formula, NC0 is always 1. NC0 is always 1. Let us solve another thing, that is 4C2. 4C2. What would be 4C2? N factorial, that is 4 factorial, divided by r factorial, that is 2 factorial, into n minus r factorial, that is 4 minus 2, that is 2 factorial. Now see, break these 4 factorials. 4, 3, 2 factorial, divided by 2 factorial into 2 factorial. This 2 factorial cancels out. What would be 2 factorial? 2 factorial would be 2 into 1. So we can cancel 2, 2 to the 4, that is 6. So 4C2 is 6. 4C2 is 6. Similarly, you can find out 4C3, 4C4. 4C4 would be 1 also. So NCN is also 1. NCN is also 1. If you want to calculate this, you can calculate in this way, that NCN, that is n factorial by r factorial, that is n factorial, into n minus n factorial, that is 0 factorial. N factorial cancels out, it will be 1. So remember this as a formula. NC0 is 1, NCN is always 1. After that, calculate the powers, simplify, you will get the answer. Now second question, using binomial theorem, expand this and hence find the values of this thing. Here see, we have odd powers. We have just we have seen those two formulas, right? Plus and minus. So x plus y to the power 5 plus x minus y to the power 5. We know that this formula is going to be up to even terms, right? In 5 we have 5, but in addition we will go up to even terms. So 5c0 x to the power 5, 5c2 x cube y square, 5c4, that is in the third term, that is this is the third term, and then 5c4 x to the power 1 y to the power 4, x to the power 1 y to the power 4. See, we have formula, this formula, right? X plus a to the power n plus x minus a to the power n is twice nc0 x to the power 1. Compare this with this thing. X is your x and a is your y. So first term would be twice. In the addition term, we get the even terms. So nc0, that is 5c0 x to the power n. What is x to the power n? That is x to the power 5. Then a to the power 0, y to the power 0 is 1. Next term would be nc2, this would be 2, nc2 x to the power n minus 2, 5 minus 2 is 3, then a square, that is y square. Next term would be nc4, that is 5c4 x to the power n minus 4, so 5 minus 4 is 1, and next a to the power 4, that is y to the power 4. Next term, what would be the next term? Next term would be NC6, but here we have 5, up to 5, so we have to take up to 4 here. So calculate NC 5C2, 5C4, you calculate, just I have shown in this manner, you will get it as this: twice x to the power 5, 10x cube y square, 5x y to the power 4. Now put x equals to root 2 and y equals to 1, you will get this, right? X equals to root 2 and y equals to 1. Here x equals to root 2 and y equals to 1. Put the values, calculate, you will get 58 root 2 as answer. Next question is prove that summation r equals to 0 to n NCR 3 to the power r is actually 4 to the power n. See, from the right hand side we can see that it can be written as 1 plus 3. So that is our basic assumption. So our expansion would be 1 plus x expansion. So 1 plus x, what is the expansion of 1 plus x to the power n? NC0, NC1x, NC2x square, right? So in general formula we can write this as 1 plus x to the power n would be summation r equals to 0 to n NCR x to the power r. Put x equals to 3 in both sides, so 1 plus 3 to the power n, that is 4 to the power n, would be NCR, that is NCR into x is 3, so 3 to the power r. See, we have just proved this thing. So let us see another problem, which is larger, 1.01 to the power 160 or 10,000, which is larger. So you have to start this something like this, that this thing minus 10,000. Now apply 1.01 can be written as 1 plus 0.01 to the power this thing minus 10,000. Now apply the expansion, binomial expansion, NC0 a to the power 1 into b to the power 0. So see, here one term is 1, so we don't have to take into consideration the a terms, we have to take the consideration of b terms. So b to the power 0, that is 0.01 to the power 0 is 1. So first term would be this thing NC0, second term would be NC1 b to the power 1, NC2 b to the power 2, in going with this NCn b to the power n minus 10,000. See, in this thing we can write this thing as NC0, we already know NC0 is 1, so NC0 is 1, NC1, see NC1, what is the value of NC1? NC1 would be n factorial divided by 1 factorial into n minus 1 factorial, right, n minus r factorial. So n factorial we can write it as n into n minus 1 factorial divided by n minus 1 factorial, because 1 factorial is 1. So n minus 1 factorial, n minus 1 factorial gets cancelled out, so it would be n. So NC1 is n, remember this also. So NC1, so NC1 is our n, so n into 0.01. So in going with this, we can write these terms, keep these terms as it is. So we can say that other positive terms are these things, minus 10,000. So see, 10,000 gets cancelled out, so we will have 1 plus some other positive terms, that is 1 plus something, 1 plus some positive term that is greater than 0. So we can say that this thing is actually greater than 10,000. So that means this is greater than 10,000. Next question, using binomial theorem, prove that 6 to the power n minus 5n always leaves the remainder 1 when divided by 25. This is an extremely important type of problem. This may come in your exam, so stay concentration. 6 to the power n minus 5n. We can write 6 to the power n as 1 plus 5 to the power n. So again expand this as a plus b whole to the power n, or x plus y whole to the power n. NC0, NC1 into b to the power n, because our first term is 1, right? b to the power 1, b to the power 2, b to the power 3, going like this, minus 5n. NC0 is 1, we already know. NC1 is n, we already proved this. NC1 is n, so 5C1, NC1 would be n, so n into 5, so 5n. Keep the rest of the terms as it is. So 5n gets cancelled out, keep 1 in the left hand side. So from this you can see that we have 5 square, 5 cube, 5 to the power 4, so we can take at least 5 square common from this all the remaining terms. So 5 square common, NC2, NC3 into 5, then 5 square, this would be our remaining things. So 5 square is 25. 25 multiplied by some integer values. 25 multiplied by some integer values. Now take 1 in the right hand side. So 6 to the power n minus 5n would be 25 multiplied by an integer value plus 1. So see, if you divide this thing by 25, this thing will be divisible by 25, but this 1 will be remained as remainder. So 6 to the power n minus 5n leaves the remainder 1 when divided by 25. Again see, 6 to the power n minus 1 divided by 25. So this whole thing is divided by 25. That means this thing is divided by 25 plus 1 divided by 25. This thing is divided by 25 because 25 gets cancelled out. That means this is divisible, and 1 divided by 25 is not divisible. That is 1 is a remainder. So if you divide by 25, you will get 1 as a remainder. This is our first video regarding binomial theorem. We will upload second video as well as soon as possible. Thank you. All the best.